So I want to welcome you guys. This is John Dillon. Everyone else knows him.
That was Steve. And I know everybody knows him.
That was your introduction.
Okay, thanks. So this is numbers 9 and 10 of the 15-part history of astronomy before there were telescopes. So we're about 2/3 of the way through it. But this is the one that I always have a little bit of concern about, because it's got to show somewhere in the listing the word medieval. Hard to get around that, but the word medieval is a pejorative in our language, and it doesn't really apply to the topic of the history of science very well. It's a case I hope I can make tonight. Most people relate it to dark, superstitious times when people in black robes were torturing, or others are burning people at the stake for heretical ideas in science. None of that's true, just way off. It gets pretty true after the Reformation. That's a time when you can start thinking those kinds of thought. I mean, the Spanish Inquisition was a bad time, we'll agree to that. But that's had nothing to do with science, and they kept it down south of the Pyrenees. So I'm going to talk, I lumped together 2 half-hour talks, and I'm going to expand on both of those, but I'm going to try and not run too long tonight. So I'm going to combine what happened in what we could say is medieval Islam and Europe together, because they are connected in many ways. First thing I'm going to do, though, I apologized earlier for adding philosophy into this series. Now I have to apologize for some hardcore history, but I'm going to compress this into a very short overview that I think is essential to understanding some of the stuff that follows. So after Alexander's empire, which extended all throughout here, after he dies, it breaks up shortly afterwards. The Roman Empire that takes over much of that couldn't hold on to this territory in here, and we've got the Persians reemerging as a new culture. It's called the Sassanid Empire. It's an old, ancient, literate culture, always been at war with the Greeks for a couple thousand years, it seems. And now that emerges. Now they had a tradition that the central figure of their religion, which is Zoroastrianism, Zoroaster wrote a 12,000 volume encyclopedia of all the knowledge in the world. It's their legend, they can do whatever they want. But when Alexander came in, he found that, translated it all into Greek, burned the originals, and took all that back to Alexandria, and that was how the museum at Alexandria got its start. That's the story of the Persians. So now that they've re-emerged as their own culture, there is the feeling that some of those ancient texts still exist, and they're sending out now to find them. In India, there's this golden age called the Gupta Empire. They think some of that, maybe some of their tradition may be there, particularly in medicine, a bit of astronomy, and especially what they're going to find is some new math, at least certainly a new way to use numbers, express numbers, and when they get it, it'll end up eventually being taken over by the Arabs, and when it gets to Europe and to us, we'll call it Arabic numerals, but it came through Persia from India. They also send to China a little bit of stuff there, a bit of exchange along the Silk Road, not a lot, mostly medicine, but the Byzantine Empire, which is the Roman Empire that's left after Rome falls, they had a fit of orthodoxy that took over. It's now a Christian empire, and there was a period at which they closed down Plato's Academy. They closed down all the schools. The Lyceum of Aristotle is gone. There was a famous Syrian center in what is now Turkey that closed, and the suppression from this religious fervor in the Byzantine Empire drove many of the intellectuals from Greek pagans into the arms, the welcoming arms of the Persians. And the Persians set up a school at a place called Jundi Shapur or Gandhi Shapur, various spellings. And it became the intellectual center of the Persian Empire. It also became the foremost medical center in the whole world. A lot of translation goes on here. Now they have access a bit in these directions, but all the Greek material that we talked about earlier, Aristotle and Ptolemy and the rest of it, is now going to be translated into Persian and kept there. Now, Persia and the Greeks are continually battling, and there's a point at which the Byzantines have a pretty successful campaign, greatly weaken the Sassanids, and it just happens to be a few years before the Arabs get their act together and with this incredible fervor come roaring out of the Arabian Peninsula, meet two cultures that are greatly weakened, and they take over very quickly much of the Syriac-speaking part of the Byzantine world, Syria, and all of the Persian Empire. And there's a map that shows you some of the conquests, and look how rapid this campaign is. They spread across North Africa, go up into Spain, all the way over to India and the Indus Valley, and they set up their first, well, I went a little quick, they set up their first headquarters in Damascus. It's known as the Umayyad Caliphate. When they set up a headquarters here, these are people who knew of themselves that they were tribal. Their history was factional tribalism. They now have a huge empire, and they're aware of the fact that their cultural background really isn't good preparation for administering a huge bureaucracy of a big empire. So what did? They took over the Greek-speaking Byzantine approach. The people that are still living here, many of whom didn't feel comfortable under the Byzantines, are now glad to help the Arabs. And the Caliphate adopts Greek as its lingua franca. It does business in Greek. But remember, the Greeks at this time, in the fits of orthodoxy, are not interested in their ancient science and philosophy. And so the Arabs here also aren't interested in translating anything. About 100 years after this, by the time that they're going up into the south of France where they get stopped, about the same time there's a civil war, and a new caliphate is set up in a brand new city that didn't exist, and that's Baghdad. It's called the Abbasids. But now they're in the heart of the Persian country. And what's going to happen is they're going to inherit the Persians' desire to collect information, translate from other cultures, and it's going to be continued and amplified by this new group. So they set up a new city. The caliph, first caliph, Al-Mansur, brings in a Persian and a Jew to advise him on what day to found the city based on astrology. And so that's why it has a very specific day when it was founded. And notice the original city is perfectly round. Not hard to see the connection with astrology there. Now the city is going to expand and become probably the biggest city in the world beyond that. But the ancient original city very much related to the geography of perfect circular motion of the things in the heavens. And one of the first books that they translate and becomes the Bible for astrologers is Ptolemy's Tetrabiblos, if you remember that. That was the 4 books he wrote on astrology. They got put together and given the name by somebody else. It wasn't Ptolemy's name, of the Tetrabiblos. A couple generations later, the grandson or great-grandson, I guess, of Al-Mansur, the caliph is Al-Ma'mun, And he's the one that sets up the famous House of Wisdom. And often this is referred to as the Islamic version of the museum at Alexandria, but it's not very similar at all. It's a place for translation, or it's certainly a place for books. In fact, the phrase House of Wisdom is a direct translation into Arabic from the Persian for a library. So they're now using Jandi Shapur, that I mentioned before, and the people who work there, bringing them to Baghdad and setting up a translation process that's going to last quite a while. And the first person they bring in is Al-Kindi. He's an Arab. And by the way, I mostly avoid using the term Arab to describe the various scholars and astrologers and philosophers, because very few of them were Arabs. It's an Arab empire. Arabic is the language that everybody speaks and what works are written in, but there's a wide variety of cultural backgrounds. Many are Persians. Al-Kindi, though, is one of the famous Arab astronomers, philosophers. In fact, he's referred to as the father of Arabic philosophy. And a warning, from now on there's going to be a lot of guys named Al. You just have to get used to that. And what he begins translating, and when they discover Ptolemy's mathematical syntax, that was the Greek title for it, and they see how incredible this is compared to the poor systems that they were aware of for figuring out the position of the planets, sun and moon in the sky. This thing is really amazing. And so they give it a new name. They take al, the specific article from Arabic, and put it with the Greek word for great, and this becomes the Almagus, the greatest. It's just referred to that way from then on. And it really is the Bible for computing the position of things in the skies. And this begins about a 200-year period of vigorous investigation, translation, and research, adding to the things they discover, primarily from the Greeks, but other sources as well. Here's another guy named Al, philosopher, astronomer, astrologer, somebody who's interested in everything. And this is typical of the people we're going to see in this period in Islam and then later in Europe. The most famous astronomer or astrologers are also pretty knowledgeable about medicine, philosophy, mathematics, and so you'll see the word associated with the Islamic scholars. The Arabic word is Hakim. It'd be like Leonardo da Vinci or something like that, and there's some other examples I'll show you. And it's common. You don't specialize yet solely in one of these narrow fields of scholarship. Generally, you'll see the whole range covered by people who are bright enough to cover any one of them. They tackle the others as well. Now, Al-Battani is going to develop an ephemeris, and the Arabic word for an ephemeris is zij, so there's a lot of zijes, and they have their own special names. And generally, what will follow it is who wrote it or where it's from. But just to give you an example of the quality of the work he could do, calculating the length of the solar year is quite a bit more sophisticated than what we had seen in the Roman period. Not quite as accurate as Hipparchus, but still a big improvement over where things were in the Byzantine Empire. Precession, his figure is better than Ptolemy's. Ptolemy's is quite a bit off, and we'll get back to that later because it has some significance in tracing who used Ptolemy and how. So he's doing very good astronomical work. And one of the things he discovers is the size of the moon changes throughout its cycle, and he's the first one to predict something that nobody had seen, or at least nobody had recorded. I'm sure somebody had seen it, but there's no records we know of an annular eclipse. And Al-Battani predicts that it is something that will happen, and in fact did. Now, his work gets translated into Latin. Not everyone's does, but the best of the Islamic scholars do get their works translated, and if that's the case, then we end up with a Latinized version of their name, and his name becomes Albategnius. And most of these guys will have craters on the moon with the Latin names, and you may recognize some of them. But notice what he has in his hand. Okay, this is the big observational device that's been referred to before. It's the astrolabe. Hipparchus probably first designed this. Certainly Ptolemy made use of it. But when it gets to the Islamic world, like so many other things, it's not just protected and used and passed on. It's further refined. And there's a lot of improvements made to it. The other observational device that drives astronomical interest is the Qibla. The direction to Mecca is really important. And with many cultures, the basic calendrical rites or religious rites that are tied to the calendar require that you know something about astronomy. So if for no other reason, there will be strong competence, interest and competence in knowing how to chart the position of things in the sky so that you can set the prayer times during the day, for instance. Works in the medieval European world that way as well. And they designed many other kinds of instruments, some very arcane ones. In the Quran, there are several places where there's reference to the stars and the value, and here's one that sort of encourages people to be aware. Knowing their way around the skies helps in learning your way around vast expanses of the desert or the sea, for instance. Al-Sufi is probably the most famous of the scholars who did a star atlas, and here's a page from his. It was called the Book of Fixed Stars. By the way, he is a Sufi. That's one of the sects. It's the mystical sect of Islam. Not only did he do a star atlas, he wrote about other things as well, the astrolabe. He described not just how to use it for the stars, but he described 1,000 different uses of the astrolabe. It can be used in surveying and timekeeping and navigation, a lot of other things. He also took the traditional Arabic constellations and compared them to the Greek constellations. They weren't exactly the same. There's some that overlap, and here's one where you might recognize the overlap because they've used a centaur as well as the image that could be somehow displayed by connecting the dots there. The other thing that's generally known about Al-Sufi, pretty special, he was the first one to refer to that great fuzzy patch that is in Andromeda, the galaxy, and he put it into his star chart. It's something that could be seen naked eye, but apparently that was the first description of it. He called it a little cloud. But what's more amazing is that he also referred to the Large Magellanic Cloud. Now, that's something you can't see from where he was working up in Iran. But the Arabic world, of course, Arabic language extended far south, and astronomers in Yemen were able to see the Magellanic Cloud, so that was in his star chart as well. Europeans didn't see it until Magellan, of course. That's why we give it that name. Al-Biruni, another Hakim, he's the first one to study in India. He actually travels to India to learn what they knew, which means he also picked up the math the new number system and how to use it. And he applied mathematics to the use of the astrolabe, the use of the armillary sphere, many other things. Islamic astronomy becomes much more mathematical because of him. He's not interested in astrology at all, and we'll see there's quite a spectrum in Islam and in Europe too. People who are very religious and those who are not so religious and those who are anti-religious. All of this spectrum can be evidenced at various times and places. He also said, the rotation of the Earth in no way impairs the value of astronomy, as all appearances of an astronomic character can be explained quite as well according to this theory or to the other. What he's saying is something we'll hear again and again. Maybe the Earth rotates on its axis, or maybe even it orbits around the sun. This is an idea that's continually up in the air, so to speak. You know, it goes all the way back to the ancient Greeks. Several of the Greeks talked about it, but it pops up again in the Islamic world and again in Europe. We don't have to wait for Copernicus to, you know, bang his forehead and come up with a new idea. It's an old idea, and it's not out of the discussion for very long anywhere. Early on, they made some observatories, and the biggest one in the 9th century is in Isfahan, which is in Iran, and near Tehran. And one of the things that observatories are careful to do is to have a sighting device that's accurate for figuring out the obliquity of the ecliptic. And this is a place that is able to get much better observational data than had been had before. But notice there are other kinds of instruments here, and it's interesting how many different ways they developed for using trigonometry and algebra and sighting arms to figure out various astronomical issues that they wanted to be more exact about. A name that was important at the Isfahan Observatory may surprise you. We know generally this name in another context. Omar Khayyam was another Hakim, and not only good in all the sciences, but he was a very good poet as well, and that's where in the West most people connect the name with the Rubaiyat. But he headed up the observatory for a while and oversaw the development of their calendar, which was a big improvement over what preceded it. Certainly a big improvement over the Roman calendar, the Julian calendar, almost as good as the Gregorian calendar, which won't happen for another 500 years or so in Europe. And here's another person who was opposed to astrology and said so. This is a name that is really important in the history of optics. Again, a Hakim, and he wrote about nearly every subject. But his book on optics is one that becomes translated into Latin. That's why we have a Latinized name. And this is one that makes significant improvements over anything that the Greeks did. There are several examples in other areas as well, but this is the one that's so obvious. This is, by the way, a poster that Bosch and Lohm used to put out to put in the offices of ophthalmologists. It was promoting the Bosch and Lohm, but I'd love to have the whole series. But he talked about how refraction worked in terms of a difference in the speed of light through different materials. Rather sophisticated stuff. He also talked about the moon, the light from the moon, everybody knew was reflected from the sun, but of course Aristotle said that everything up there is perfectly smooth, made of ether, the fifth element. So Alhazen points out the obvious. Wait a minute, it can't be just a reflective, smooth reflective surface. What do you see if you have a perfectly smooth sphere and shine a light on it? You don't see the sphere, you see a point of light where the angle from the sun hits it at the right angle to come back to us. Galileo's going to make this same argument years later, and he's probably read this. There's also a lot of interesting stuff that happens in Spain. Al-Andalus caliphate is set up there when the Umayyads, that first caliphate in Damascus, is in the midst of the civil war. A prince of that caliphate runs across North Africa, makes some Berber friends, and goes across into Spain, and a very rapid conquest there, driving out many Christians, but not all of them. A lot of Christians remained behind and learned Arabic, and they became known as Mozarabs. Of course, there were Jews there as well. There probably were Jews there before there were Christians. And it's an interesting story and very complex one. And most people have heard the generality that the golden age of the Al-Andalus was a time when Jews and Arabs and even some Christians could work together so well. Great progress is made. But it doesn't account for all the many centuries in which there was Islamic control there. And it goes back and forth. Who are the good guys? Who are the bad guys? Who's being tortured and by whom? There are even times when Jews are in charge of the armies, going after Christians. There are times when fanatical Muslims are called to defend the Muslims in Spain against the Christians coming down. The fanatical Muslims come across Straits of Gibraltar, go up into the big cities and look around, and they see all these Arabs with fine silk clothes, jewelry, with perfume on, and it's obvious what to do. They slaughter them and destroy their libraries because that's not proper Islam. So, it's a complex story back and forth. So the point that I wanted to make, the Golden Age generally is referred to as an area around 1000 CE, headquartered in Cordoba. But the greatest scientific progress, most interesting stuff, didn't happen really at that time as much as slightly after, when the caliphate broke apart and there were a lot of these separate kingdoms, they're called taifas, competing with one another, and this is when you get some exciting new things happening. And it's another example of a point I made very early on in this series. The ability to do science implies the ability to argue, sustain an argument in a common language generally, when there's not an overriding force of bureaucracy or dictatorial mandates or orthodoxy. And it's when the caliphate broke up that you see that liberating some scientific discussion and progress. And this is also the place where Europe will gain its first access to the Islamic science. Now, I just want to point out one of the big names from Spain. There are many others, and we're skipping over a lot of stuff because it would just be hard to get through it in an hour or so. But amongst the Jewish scholars, the most famous is Maimonides. He wrote a book called Guide to the Perplexed. He's pointing out that Ptolemy's system is very good at generally good at calculating the position of things around the sky in the circle. He does it with these epicycles, though. That means that the planet's going in and out, in and out. And it doesn't make sense philosophically in terms of a system that would really work well. How do you have planets going on big epicycles like that? On the other hand, Aristotle's system is good philosophy. It's that nested homocentric spheres, all centered on the Earth, and each sphere carrying the moon, sun, the planets, which is nice and made of a fifth element. It's nice philosophy, but it's not very good at predicting where things will be in the sky. So Maimonides says that's why the perplexity here. He says, from his point of view, God is really making it clear that the place to direct our attention, our philosophy, and our science is here on Earth. Let's look at the things around us and work out some sort of philosophical understanding of that. What's ironical here, I think, is that history demonstrates just the opposite in terms of the development of sciences. It's astronomy that becomes a science first, and earth science and biology have to wait centuries before some coherence is made with them. By the way, there was a period of fanatical time in the caliphate that being Jewish wasn't the healthiest thing, and he had to flee to a different caliphate in Cairo at the time, but eventually returned. So the Mongol Empire had been expanding back and forth and attacking China, and now sweeping across to the Eurasian landmass, and eventually conquer Baghdad. In the year 1258, Baghdad falls to the Mongol army led by Hulagu Khan, and the famous saying that's been used to describe this is the river ran red with blood and black with ink. Everything was destroyed. All the libraries, the hospitals, the observatories, people were slaughtered, dreadful time. However, and this was a place that had a huge library. It was also past its prime. Another thing should be pointed out. Baghdad was still an important city because it had been important, but the golden age had passed it by. However, there were still things of value in that city, and there was an astronomer whose name is Nasser al-Din Tusi, often called Tusi, which he probably wouldn't like, but anyhow, you see his name written as just Tusi. He, as the Mongol army is invading, grabs somehow, he must have had help, 40,000 books, manuscripts, and flees Baghdad, probably goes to Cairo. But then, a year later, starts thinking this through, and goes back and talks to the Khan, the Hulagu Khan, into building the best observatory in the world. And his case is, you won the battle, you conquered Baghdad because the value of astrology. People who knew astrology and could predict your success. You need to have an observatory really good so that you can continue the success of your dynasty and empire. And so he built the Maragha Observatory in Iran. Actually, it's in Azerbaijan today, but part of Iran then. And those 40,000 manuscripts that he rescued were taken back to the observatory and became a centerpiece of international value. And in fact, for the next 50 years, people from all over the world, literally, would come, well, not the New World, but China, the Middle East, even Byzantines, which means Europe, and they would study here. In fact, there were some Islamic scholars that were sent to the observatory in Beijing at the request of the emperor there to help them get started with their own observatory. Now, one thing that Tusi did that's going to have a big impact later, he figured out how to draw a straight line using two epicycles. If you work it out right size diameter at the right revolutionary speed, you could draw a straight line, which meant he found a way to use epicycles to overcome something that almost everybody hated about Ptolemy. And I pointed it out in earlier lectures, where he had a point off center. If here's the world, the Earth's in the center, here's the orbit of a planet, off center in a point he called an equant. He had the motion of the planet appeared to be moving uniformly in a circle, but in fact, if it was off, you're looking at it off center, it couldn't be going uniformly. It would have to go slow and fast, slow, and fast. And that violated the principle of uniform circular motion that Greeks and Islamic scholars and Europeans will all hate. And here was a way to overcome it. In fact, there's another Arab scholar who is in Damascus, that still remained a fairly important city, who figured out how to use it in working out the motions for Mercury, and I think for the moon. And he wrote it up in a book called The Final Quest Concerning the Rectification of Principles. The rectification was fixing Ptolemy so that it no longer violated uniform circular motion. What's interesting is that he made some strange little errors in how he set it up that appear exactly the same in Copernicus' work 200 years later. How Copernicus would have known about that is a subject that historians of science have been continually searching for. There are several possibilities of second and third hand transmission of this work because it apparently didn't get translated directly into Latin. But it appears that Copernicus somehow knew about this and made use of that same thing. Related to that, not knowing the details, is the fact that there's something like, well, there are tens of thousands of manuscripts in Arabic today that have never been translated. And there's a big industry of people at work now going through that material, finding out what is it about. In most cases, it's stuff that wouldn't be of interest to scientists, but there is some stuff that I think likely will change our perspective on many things, including some of these more critical aspects of what the Islamic world did contribute to the European world. But that's work that's going on now. Now, after the fall of Baghdad, it's pretty clear, except for the Marga Observatory, not much else is going on. The golden age is past. There's not a lot of new research, but as I said several times, what's interesting, the first science to appear in almost any culture is astronomy. The last science to disappear as cultures fade and crumble is astronomy. They always want to cling to that for the calendrical and the ritual aspects. And so here, late in the Islamic world that we're talking about, in Samarkand, another Mongol sultan, Ulugh Beg, builds the largest observatory in the world. And this is the only part of it that's still in existence, an underground part of a sextant, a sixth of a circle. It's 118 foot in diameter. And with this, they were able to make observations, for instance, on the ecliptic, the angle of the ecliptic and other things, so that the accuracy was down to 3 arc minutes, naked eye observation. Now, I seem to recall that Hipparchus was only able to see things down to half a degree or 30 minutes. I'm not sure of that, but this is much more accurate than anything that the Greeks were doing, but you're doing it with something that's 118 foot in diameter. The star catalog, the ephemeris, I should say, the ZIJ, that was produced as a result of the observations here, became the greatest, most accurate catalog between Ptolemy and Tycho Brahe, that we'll get to eventually in a couple months. It was at least as good as Al-Sufi's catalog, and in some areas more accurate, just because of the bigger observational instruments available. 20 years later, this is destroyed by religious fanatics. It's a common theme. So we're coming to the end of what we call the medieval world of Islam, with the overthrow of Constantinople. The greatest building in the world, Byzantine building, becomes a mosque. The city changes names. And shortly after the Turks take over, they build an observatory as well, and modeled on Mariga. However, 3 years later, it's destroyed by religious fanatics because an astrologer there at the observatory had predicted the success on a battle with the Persians that turned out to be a disaster for the Turks, and so off with the head of the astrologer and off with the observatory. So not much is going to happen in the Islamic world. It's interesting, even after telescopes are invented in Europe, throughout the 17th century, telescopes are not used in any of the observatories in the Islamic world. There's some in India and the Mongol Empire, various places, but they stayed with naked eye observation. So a final sort of overview, a wrap-up of what's the story with the Islamic science. The way I learned it and the way it was taught up until fairly recently, and you still see it in a lot of books, is the Islamic world got and protected and improved on a little bit, but cared for enough Greek science so they could transmit it back to Europe. It was important as a way to protect and transmit ancient Greek astronomy, mostly ancient Greek astronomy. In the last couple of decades, there's been a revisionist view, and a lot of it fired up to what's happening in the Islamic world more recently, that actually the scientific revolution happened in the Islamic world in this medieval period, and that modern science owes its origin to that time and place. What I will tell you is the prominent view amongst historians of science is in between those two, that the Islamic scholars not only received stuff from Greece and other cultures as well, but greatly enlarged on it. And in many cases, like in Al-Hazen's case, he was actually doing something that we can call the scientific method, making hypotheses, observations, and testing those hypotheses, and writing them up so that others could check and see if they could get the same result. The best of the Islamic scholars, Al-Kindi, Ibn Sina, we didn't talk about much, and Al-Hazen, they were as good as any of the names we're going to talk about now as we get into Europe. They equal the best of the Latin West. There wasn't a scientific revolution, I don't think, in this period, in this place, as there will be in Europe when we get to the 17th century. But it's important to understand that the West and the Islamic East and other cultures as well are part of one common philosophical, theological, scientific heritage. And particularly among the monotheistic religion, there's a lot of times and places where there's a mixing of the knowledge of all of those cultures. And it's important to see the contributions as not being one-sided. So, we're going to get to Europe now. Well, back up 1,000 years. The Dark Ages. The term medieval, Middle Ages, Dark Ages are not terms that were designed or coined by modern historians. Those words were coined by the people in the Renaissance because they had reborn culture. They rediscovered the ancient Roman Greek cultures and they improved on it, and the Renaissance means rebirth. So they gave the name Middle Ages to the people that were in the middle, and at the very beginning of the Middle Ages, that was the dark period. Well, I mean, truth be told, it was when Rome fell, it disrupted pretty much everything. Commerce, traffic on roads, road repair, it all fell apart. Cities that depended on that started losing population out to an agrarian community and culture. In fact, the only literacy and literature that was found much of anywhere in Europe was in the monasteries. And remember, and I pointed this out earlier, the Romans weren't interested in the ancient Greek science and math. It was too hard unless it was a watered down version. So Ptolemy doesn't get translated into Latin. He's a citizen of the Roman Empire. They don't translate his work into Latin. So these folks are not going to know anything about Ptolemy. They aren't going to know anything about Aristotle, or just a wee bit by somebody who wrote the best that he could remember while he was in jail, a guy named Boethius, and a few things here and there. And in fact, there was another reason we could think of this as a dark age. It's just been worked on in the last few years. There's evidence that there was a mega eruption, probably volcanic, maybe an astro effect here, but more and more information, I think it's volcanic, that blanketed the northern hemisphere for a decade. Huge climatological and cultural impacts are just now being worked out. For instance, the Byzantine Empire, right after this, within a couple years, lost half its population to the plague. That's the way it was recorded in history. What extent a darkened skies. Here's a Byzantine phrase of record of what they saw. So that obviously had a negative effect on culture generally, and who would go out at night and look at the stars, etc. Here's the best example of what the so-called Dark Ages would have been like intellectually. In Spain, before the Arabs get there, St. Isidore in Seville writes a book of he calls Etymologies. It's going to be 20 volumes of all the knowledge that he knows about. This is going to be the encyclopedia of the natural world and more, other focuses as well. And here's the 20 books. One of them is on astronomy or astrology, but knowing the heavens. Now, he's a collector of facts. It's secondhand, third hand. There's no fact checking going on here. Rumors are good too. And what does he have to base it on? Not much got translated into Latin. Unfortunately, the one thing that did get translated by somebody who was a noble Roman, who made sure his work got promoted because it was written in Latin, is Pliny the Elder. You've probably heard of him. He wrote a book called Natural History, which he boasted was a collection of 20,000 facts. I think I mentioned him in an earlier talk. 20,000 facts. He should be called Pliny the Credulous, because anything he was told, he believed, and he put it in the book. No fact-checking there either. So St. Isidore is writing a book, second and third hand, rumors and facts mixed together based on Pliny, his mix of fact and rumor. And believe it or not, in 2001, the Catholic Church, because this became the source book of information for the next 200 years, they made him the sacred saint. Patron saint. Sacred paint is awesome. I like that better. Sacred paint. And he's Saint Internet. I mean, it's just perfect. I don't think the church was aware of that. What's that?
It is perfect.
Yeah. Anyhow, I don't know if any of you remember when personal computers were first becoming popular, there wasn't a lot of software available, and this kind of stuff was referred to as shovelware. You put it on a disk and sell it. So anyhow, that's what they have of pseudoscience available. But they also had this. It's called the computus, which was the way to figure out when to celebrate Easter. Now, when do Christians celebrate Easter? The first Sunday after the first full moon, after the vernal equinox. The problem is you can't look up in the sky and figure out when the full moon is. You would think that would be easy, but you got to know exactly when it is. You can't tell exactly when the vernal equinox is either. I mean, the moon might be full not during the night. It might be during the day. So to be exact on that, which is really important because this is the most important rite in Christianity, got to get it correct and get the rite right. They had something we've mentioned before to rely on. Remember the Metonic cycle? The Babylonians discovered that 19 years work out almost perfectly, equaling 235 synodic months. The phases of the moons line up over a 19-year period, so all you need is a chart and know how to read it, and you can tell the bishops when to celebrate Easter. This was a cause for numeracy amongst the clergy, just as the Bible was the cause of literacy. Those are the two things that kept those two skills going in the darkest of this time. But in the 8th century, there's a little bit of a renaissance. Now, when the Arabs come roaring across North Africa, go up into Spain, they got stopped in 730-something in the south of France by Charles the Hammer, and his grandson, or great-grandson, Charles the Great, Charlemagne, is going to decide it's time to renew the Roman Empire. It's Christian now, so it'll be the Holy Roman Empire. The classical joke amongst historians, of course, is the Holy Roman Empire is none of those three things. But what he revives is the way the Romans taught their children, at least the children of the elite, with the 7 liberal arts. 3 of them are based on language, rhetoric, grammar, and logic, called the trivium, and the quadrivium, the other 4, based on math, include astronomy. And now we're going to have, because of Charlemagne, a school at every cathedral. And this approach of the liberal arts and the trivium and quadrivium will last all the way up into the 19th century. Charles Darwin had to have a course load based on that. But while at this time, while the caliphs in Baghdad are reveling in their ability to read Greek and Persian philosophy and science, the Holy Roman emperors are delving into the thrills of writing their name. But things are going to change pretty quickly. Gerbert of Aurillac is in a monastery in the Pyrenees. Now, the Pyrenees are separating Islamic Spain from Christian Europe. And he, the story goes, starts sneaking out of his monastery and starts spending time talking to the folks down in the Islamic world and discovers some of these amazing things they know. He learns about the armillary sphere. He also learns about the astrolabe and how to use it and what it means. And he then goes to a cathedral school, and especially at Reims, and begins teaching the new science, new Islamic science, and especially based on these astronomical tools. And the other thing that he learns about from the watered down translations, not even translations, the watered down remembrances of Aristotle in Latin, he learns a little bit of Aristotelian logic. And so he begins a curriculum at the cathedral school based on the 7 liberal arts and the use of logic, demanding that it's logic and reason, not authority, that should be the guide to how to learn the sciences and philosophy, etc. Pretty important, except even more significant, he gets a promotion. In the year 1000, he becomes Pope. Here is the person who probably knows more astronomy than anyone else in Europe, at least as much as anyone else, and he's Pope. And he says reason should be driving your education more than my authority. That's pretty strong words. Now, the word medieval, as I said before, is a pejorative. It dredges of images of malevolent, superstitious people, heretics being burned at the stake, and the rest of it. And I just want to make clear that does not apply to the period that I'm talking about tonight. Okay? In fact, it's almost the obverse of that. Not that there aren't periods when people get nasty, some people get hurt a bit, but there's no contest between science and theology as is the popular image has it. All that will change in another 100 or 200 years when Martin Luther gets the Reformation going. But nothing illustrates the dynamism and the exuberance of this period than a medieval cathedral. Some of you have been to a medieval cathedral. I don't know about you, but I find this as awesome as any modern building I've ever been in. Imagine somebody at this period coming to the big city where there's a cathedral. Now, there had been fairly large buildings before, nothing quite so large, the Hagia Sophia being an exception, but they mostly were dark and dank. Here's a huge building that has windows all around it with colored glass, and you come from a place where you've never seen anything bigger than about that, made of wood. Let there be light, a place to focus religious intensity. Huge impact on people, and it expresses the general feeling. The other thing that's going on is a major climatological change. The climate gets warmer in the 11th century to the point where the Vikings are no longer raiding down south, which destroyed the sense of permanence of a lot of towns and educational centers. They were always on edge. The Vikings were able to raid up rivers. It was a very destructive influence for quite a while, but with the weather better, they're now heading to the west, Iceland, Greenland, Nova Scotia, Labrador, wherever. And with that warming of the climate, agriculture explodes. There's some new technologies. They figured out how to put a collar on a horse and use a horse as a draft animal, which they hadn't been able to do before. New seeds, new kinds of things are being grown. There's an explosion in the population within a century. The population of Europe doubles, maybe trebles in size. So you start getting people coming together in towns, larger towns, almost cities. Commerce is developing. The other problem, of course, you have when you have a population explosion, you got to figure out what to do with all that teenage testosterone. And what you do is you send them over to the east and call it a crusade. You have a bunch of them. That solves that problem, and it leaves the older folks alone in Europe and saying get on with more important things. However, when the Crusaders go to the east, I have this right, yeah, to the east, and they set up their own states, they're there a while, and they start seeing cities of Arabs and Islamic culture. Wow, that's nothing like that back in Europe. They come back, and their phrase that they spread, it's a phrase from, I've forgotten the name, one of the famous writers, they refer to the poverty of the West. They're aware of the fact, oh, we got a lot to learn. So where are they going to get access to that? I mean, over the Crusaders, it's hard for them to go and ask, you know, at a library to borrow a book that belongs to somebody that you're slaughtering in the name of God. However, there are times and places where exchanges can be made, and one of the places is across the Pyrenees down into Spain, and there are some cities that remain a combination of Arabic speakers, Hebrew speakers, Jews, and Latin-speaking Christians that are going to start working together, and many of these new books are going to come up to the cathedral schools. Up to this point, what did they have? Saint Internet, you know, not much. But now they're going to get some exciting new stuff, and I should point out the Greek word for school or scholar is schole, which is the Greek word for leisure. It's when you have leisure time, you can study the liberal arts. The arts are liberal because they are free of the need to do work. if you have the free time, you're liberated to study these other higher subjects. And so here's a time where commerce is booming, we're getting more leisure time and more things that are exciting to read. The population enrollment in the cathedral school starts booming, and some of the schools become overburdened. The one at Chartres becomes the most famous, the biggest and most famous. I've never been there. Has anybody been to Chartres? I want to go there sometime. It's got this incredible facade. Like any cathedral, it would have statues of saints and apostles and all that. But this one also has philosophers and proto-scientists, and then images of the 7 liberal arts. And here is astronomy up there, because pointing to the heavens. And I started trying to figure out the others. I'm not sure where they are. I think this one is music. The only one I'm pretty sure is this is grammar, because it's holding what all the grammar images showed, a birch switch. You know. Spare this birch, spoil the grammar. You know, they got to learn Latin grammar, by the way. Now, the cathedral schools populations are exploding to the point where there's more students and more teachers than can be handled by the cathedrals, and the students start hiring their own teachers. And this is a period in Europe when the trade guilds are forming. The various specialties are joining up to protect the people who can build cathedrals, for instance, and glaziers and masons, shipbuilders, etc., all forming guilds, and so do the people who want to study. And what they can do is then go rent a place in another part of town. Doesn't have to be at the cathedral. In fact, what happens is they start going to other towns that don't have cathedrals, and they set up the first universities. And this is a major change. The university degrees are what we have today. I mean, this is the beginning of a system that is going to last surprisingly unchanged. Well, one change is that it's not just for teenage boys anymore, bachelors, but at that time only teenage boys could begin a 3-4 year course on the Bachelor of Arts degree, which is the 7 liberal arts, which means that everybody who went to university started with some knowledge of astronomy. If you were more interested, you could put in another couple years and get a master's degree, which was the license to teach in any university in Europe. Those even more motivated could put in the extra years to get a doctor of philosophy, but the most educated people, the brightest people, the most revered intellectuals in all of Europe at this time were those who put in another 10 to 16 years to get the doctorate of theology. And you need to understand that status difference. It becomes really important later. You may have heard my talk about Galileo last year. By the end of the medieval period we're talking about, there's over 60 universities in Europe. Now, I did a simple calculation. It must be a ballpark figure here. Some of the universities are going to have just maybe a couple hundred students. The biggest ones, 2,000, but you got 60 or so. So every year there's going to be a couple thousand students at least getting degrees. Over the course of a century, you've got hundreds of thousands. Over the medieval period, there's likely a few million people who go through this program, this educational system, not all the way to the end, but all of them will have had an introduction to astronomy. Now, this is remarkable. There's nothing like this anywhere else in the world. There had never been anything like this anywhere else. The Roman Empire didn't have this. The Byzantines didn't have this. The Islamic world didn't have this. The Chinese, nobody had this, where you had people of a lot of different cultures, a lot of different languages, going to study the same basic subjects with the same language, continent-wide, using Latin. And how they learned is also equally important. And here's a picture of what a classroom would have been like in the medieval period. It's based on disputation, arguing. Okay? The master is going to put out a proposition whether or not something is the case. The Latin word is utrum. He would say, argue the point whether a planet moves on its own in a circle, or whether it's the sphere that's moving. Or argue whether or not a planet could go in a straight line and not in a circle. And then they would argue back and forth, and he would sort of evaluate the quality of the argument. By the way, you can tell this is drawn by somebody who's been to university. See, these people up front are paying attention. They got their textbooks open, and look at the back. I can't see in the back, so I'll give you a textbook to hold open. So, what's that? So the universities.
John, is the figure on the far right, is that a woman?
I doubt it. You mean here?
Yeah.
Yeah, I doubt it. Yeah, it's not likely. Bright women of leisure would have had tutors and had access to education, but they're few and far between. And in the nunneries, you know, there were some educated women, but not at the universities. But here you have an institutional home for arguing, and it's not just, you know, a presidential debate on TV. I mean, these are arguments based on the Aristotelian rules of the use of language, rhetoric, which they knew about, Aristotelian logic, how to take big complex problems and break them up into their logical subcomponents, a logical, reasonable, rational way to take a pro and con position on almost anything. Continent-wide, millions of people go through this. Now, Gerard of Cremona in Italy hears about Ptolemy's Almagest, but wants to get his hands on a copy and realizes the easiest place to get to at this time was go over or around the Pyrenees and find a place where it's being translated. And at this time, Toledo, I guess, is a place where there are still some Arab speakers, Jewish speakers who knew Arabic and Latin, and someone like Gerard of Cremona comes down here and he learns Arabic so that he can read things for himself, and he loves what he finds so much he stays for many years and ends up translating all of these people. He becomes the major conduit of the new access to ancient Greek and Islamic science, at least from the translations from the Arabic. Now, this is going to excite people to go after Greek originals, but that'll be a little trickier. And that happens a little bit later. Eventually, it happens in Sicily first, because that was an Islamic part of the Islamic world for a while, and it was liberated pretty quickly. So this Almagest now, in the Arabic translation version, reaches the universities, and this is really exciting. And now Aristotle is going to, in better versions, reach the universities, and Oxford and Paris become the two big ones. Paris especially, but Oxford also become major places where Aristotle is going to be the curriculum, primarily because of this guy. The Europeans also have a guy named Al, okay? Only this is Big Al, all right? Albertus Magnus. He's a Dominican, you can tell because he has a black cape on, and the Dominicans ask him to explicate Aristotle. Tell us about Aristotle. What's it mean? Not just translate it, but write about it, make comments on it. And he does that. He goes through everything he knows about Aristotle, which by this point is quite a bit. It's not just astronomy, it's biology and geology and meteorology, and rhetoric and fossils and comets and there's all kinds of things he writes on. And so the church gives him a title. He's a Hakim, but they don't give him an Arabic title. Instead, they give him titles they gave to something like 50 of these great intellects in the medieval time. He became the universal doctor and the sacred painting of the church for scientists. The patron saint of science is Albertus Magnus. Now, Paris, as I said, becomes the main university. Aristotle is the curriculum. Everybody's into disputation, having a great time arguing. A couple thousand students here at its peak. But the bishops start getting concerned about some of the disputations. And the bishop of Paris in the year 1277 condemns 219 propositions that are being taught at the university. Things like, and they're from Aristotle, that the cosmos is eternal. Wait a minute, the Bible says God created it. There was a day one. That the world's finite. Humans are eternal. There's always been people. Again, doesn't go well with the Bible. There were other things too. There can only be 3 dimensions. There can't be a void. That was a big one that Aristotle argued about. All of these things were putting limitations on God. So the bishop said, I am condemning this. You can't put limitations on God. Now, there were episodes like this in the Islamic world that brought things up to a screeching halt from time to time. But the opposite impact was felt here at the university and other universities. The people said, we can't put limitations on God. There could be a void, right? Okay, let's figure out. Let's say a planet did go in a straight line instead of a circle. That would create a void. Now, what would the void be like? Could you see through a void? Can you hear through a void? Can there be more than one world? If the cosmos is not finite, like Aristotle said, maybe it's infinite. Maybe there's other worlds. Maybe there's extraterrestrials. Maybe there's other people on other planets. All of this stuff is getting talked about because God would be free to do that, but they're going to dispute those things. And the only miracle that's pretty much accepted is that moment of creation, the Big Bang. Of course, we still sort of see that as a miracle today. We still don't have a good explanation for that. On the whole, though, in the universities, invoking a miracle was just no fun. That just brought the whole process to an end. No fair. That's always there as an out. You can always say that. But let's put that aside. Sure, that's true. We all know that's true. God can do anything. But maybe God decided to have natural laws that will explain things. Let's see if we can figure out how the natural laws work. And so invoking miracles was something that was looked down on in this time in a lot of the university disputations. Besides, if you agree that miracles do happen, how do you recognize a miracle? You have to know what's not a miracle. You have to know the natural world really well. Understand the natural world so that you can recognize a miracle. That was the argument that was used. It goes all the way back to St. Augustine. There were a lot of enlightened people, I think, that were full-blown, religious, pious Christians that could still believe that, put a lot of time and energy into understanding the natural world without miracles. Here's somebody that did a lot of that and also famously got into trouble, Roger Bacon. He was an Aristotelian at Paris, but then he went over to Oxford and he met a guy there who was teaching a new approach. It was based on Plato, but a new version of Plato called Neoplatonism. And besides, Roger Bacon was apparently having some other emotional issues, and he had an awakening. He saw the light, literally. He began to understand that light could be a key to understanding the natural world because light could be approached mathematically. That was the difference. Unlike Aristotle, who said the approach to understanding nature is the use of logic. And Aristotle says, I'll tell you how logic works, and he wrote a book on logic. But there's this new Neoplatonic system where is the emphasis on mathematics. A point of light radiates in all directions in space. It's geometrical. And they began to see that as a way to explain causation, too. Something happens here, it causes other things to happen in a radiating form out. The spheres, the creation of the concentric spheres were seen as God's Big Bang was that point of matter and light together, and light radiated everything out, created the universe. Anyhow, with that as an argument, he's going to become very mathematical about the things he looks at. And he's going to famously try his bright, active mind in some strange new areas, flying machines and gunpowder and things you've heard about, but other more legitimate subjects as well. And because of this new approach, the Pope asked him to write a book just like Albertus Magnus was requested to do for Aristotle. He's now requested to write about how to use this new Platonic, Neoplatonic approach to science for the people in the universities. And he does that, and he argues that the certainty of math will allow you to gain a certainty about the natural world. And math works very well in astronomy. So it gets a head start there. Galileo is going to use this very same argument. Roger Bacon says the language of the natural world is the language of mass. Galileo uses those words almost exactly. Now, this, while he also describes a way to do investigations. You have an observation, you make a hypothesis, do an experiment, and see if you can verify it, the scientific method again. And what is he reading that gets him fired up? It's not just the guy over at Oxford he met, but it's also Al-Kindi and Al-Hazen. He's gotten access to the work, the Book of Optics of Al-Hazen. Now, you may have heard that it's one of the classic stories, those who argue there's a war between science and religion. Roger Bacon was tortured, thrown into prison and tortured because of his writings. Not true, okay? There's many things that are not true. No one believed the world was flat at this time, and Roger Bacon didn't get tortured and thrown in prison. But it's a long digression, which I won't get into right now. This is also that during his period of investigation of optics is when eyeglasses suddenly appear. The lenses look like little beans, lentils of glass. That's where the word lens comes from. The clergy finally are able to read documents that they were memorizing for years, and it prolonged their careers, which thrilled all the younger subordinates. You can imagine, they can stay on another decade or two in the job. But Roger Bacon's going to make use of lenses. And there is this enigmatic quote from him: from an incredible distance, we might read the smallest letters and number the smallest particles of dust or sound. Sounds like he developed a telescope. There's no other evidence that he did that than this. Maybe it was just a microscope, but that incredible distance thing sounds like maybe he stumbled upon something. We don't know. Now, there was a solar eclipse in 1285. You don't get to see those very often. Generations and generations didn't know about it. Those that looked at it, many became blind. It became a thing to start paying better attention to understand. One of the things that scholars did very quickly realized you could make a camera obscura, a dark room, and with a pinhole in it, and then you could see an image of the sun on the wall and watch the eclipse that way. But there is a Jewish scholar, Levi ben Gerson, who gets a Latin name, as everybody in Europe does, Gersonides, who then uses the camera obscura as a way to watch more closely what the sun is doing in the sky. Not just during an eclipse, which he gets to see a couple years later. There's a pair of them that appear in Europe in the 14th century. But how fast the sun moves, and whether it's uniform motion, whether there's some eccentricity, an anomaly in the speed of the path of the sun, which they knew there was, but this is a way to measure it more carefully, or the size of the sun. Maybe it's changing, and he starts keeping records about that. He also introduces to Europe a thing called Jacob's staff, which is very much like what Hipparchus was using. I showed you pictures earlier. It's doing trigonometry with your observations of things in the sky. If you're sighting on the sun, that's hard on the eyes. So I'm not sure how they did that with this system. But he was starting to observe some things that Ptolemy wrote about and really bugged, as many people were, especially by Mars. Now, Ptolemy's system had epicycles of that size. It worked out fairly well to figure out where around the zodiac Mars would be at certain dates. But it required that Mars, on the epicycles of that side, sometimes was close, sometimes further away. The difference was sixfold. Gersonides makes observations. He can see nothing that would indicate more than about a twofold increase in size, or really brightness is what they're going by, I guess. And so he writes about the problems with Ptolemy, and he's one of many people to falsify Ptolemy's system, not the calculations, but the physical system. And he's also one of many people not to improve on it. Nobody really figures out how to do better than Ptolemy, but they can see there's problems there. As an example of the times, though, he dedicates one of his books to the Pope. Here's a Jew comfortable enough in Europe to dedicate a book to the Pope. Actually may help being a little more comfortable, but he lived in a fairly free, comfortable time in the south of France. Here's a fellow, Richard of Wallingford, who was an orphan, taken in by monks, very bright, so they sent him to Oxford for 15 years, does the full doctorate of theology. He develops leprosy, which could be one of many different diseases that were given that name in Europe at the time. People were shunned during the time with that. Instead, he's taken in by the monks, and in fact, eventually becomes the abbot of the biggest, wealthiest monastery in England, St. Albans. And he's a very bright guy with a good education, understands astronomy, and knows about the astrolabe, and realizes that an astrolabe, amongst the many things it can do, calculating positions of planets, etc., it's also essentially what we mean by what time is it? That is, where is the sun in the sky? And all you need to do, he figures, is take an astrolabe or something like it and have a complicated machine that can move at the right speed, at the speed at which the sun orbits, and you've got a clock. And in the 14th century, he writes a book on how to build a clock, 6 foot square, big thing. It doesn't get built during his lifetime, but a couple years after he dies, they built it. And it is the equivalent of the Antikythera mechanism that we talked about last time, which was only this big. It can do everything that that mechanism did, but it had to be 6 foot by 6 foot. So finally we got to the point where the equivalent understanding on how to make gears and machinery to show the position of what's happening in the sky equaled what the Greeks could do in the 2nd century BCE. Now, from here, there were many examples. All the towns had big town clocks. And it was incredible the things they could do. Where the planets were, where the sun was, where the moon was, the phase of the moon. Richard of Wallingford's clock could tell the tide at the London Bridge on the River Thames. This one in Prague did other exciting things. Automatons came out. But basically, look at that. It's an astrolabe being moved around to keep track of what the sun's doing. What's intriguing is this is how timekeeping began in Europe, and over time it became simplified. All of this other stuff dropped off. And it's sort of the opposite of the history of engineering, where things start simple and get more complicated. Here, things start complicated and simplify, primarily because even though the gearing was exquisite, well thought out, it wasn't very accurate. The ability to make the gears wasn't equal to the intellectual capacity of the people to design them. Off a half hour a day or so. You've probably heard of Geoffrey Chaucer and the Canterbury Tales. You may not be aware of, unless most people only read this when they're forced to, and as a freshman in college, maybe in high school too. I don't doubt if that's happening much anymore. And everybody rushes to that real ribald, risque tale, the Miller's Tale. But if you pay attention to other things in there, besides the naughty bits, it's about a young student who's traveling around with an armillary sphere and an astrolabe and a copy of Ptolemy's Almagest. Now, this book was not written for scholars. It wasn't written for a university crowd. It was a general publication for the general literate audience. It assumed, there's a lot of other science in here, it assumed people would know what an astrolabe is, would recognize some of these discussions. Sort of underscores the idea there's a lot of people in the medieval world in Europe that understood general astronomical terms and processes. He wrote, in fact, the treatise on the astrolabe, the first book written in English on how to use an astrolabe. It's getting late. Okay, well, I'll rush through the last couple guys here. A bishop in the church, Nicole Orem, writes a book in French. There's the title, The Book of the Heavens and the Earth, in which he begins wondering if a man were in the sky and could see the earth clearly looking down on it. He begins to evaluate the pros and cons. Is the earth stationary, as Aristotle says, or is it rotating on its axis? You can't tell by observation. Either could work, and he goes through all the arguments and shows that they are equivalent, although he must admit that for himself he thinks probably the skies move just because you don't sense the earth rotating. But here's a bishop of the church suggesting that. But a bit later, a cardinal of the church is now going to write some even more exciting things. He, like many others, knows that there's no parallax we can observe in the sky, in the stars, which you would expect if the earth is rotating around the sun. To see the stars from here and 6 months later here, there should be some parallax, and we see none. Now, Aristarchus boldly said, well, maybe the stars are really far away, but people sort of forgot that discussion and mainly fell back to the belief that, well, it probably is not orbiting the sun. But he says, well, it could be that they're infinitely far away. And if the stars are infinitely far away, the earth could orbit the sun, and the universe would be infinite, which is anti-Aristotelian. If it's infinite, it means there is no center. We are not the center of creation. And if there are other worlds, there could be other beings, which raises interesting theological questions. What was the relationship of God and Christ? What kind of covenants were made with these other people? But he also knew that in an infinite universe, whatever motion you were talking about is just relative to something else. All motion is relative. He also argued that there could be no such thing as a perfect circle. That in the natural world, nothing is perfect mathematically, geometric, like that, like Plato says. These are pretty stunning things for someone to be talking about. He's a cardinal of the church. And Copernicus, Galileo, and Kepler all read him. They all know about him. It's amazing that we still think of Copernicus as causing a revolution with his revolutionary new idea. Copernicus was reviving an old idea, going all the way back to the ancient Greeks, but more recently, near his time, written about and known about. And here's a high authority within the church. So this is a time when any and all questions are being asked. What's happening is that there's a feeling of the ability to have thought experiments. And not only about what is, but what possibly could be. Kind of a liberal time in terms of cosmology. It's a time when there's probably more people aware of the basics of astronomy than any time before that, anywhere in the world. No one believes the world's flat. Just get this. It makes me angry because I can remember as probably a junior high school student, and maybe some of you had this too, being told the story of Columbus having trouble with his crew because after a month at sea, they were afraid they're going to fall off the edge of the world. That lie was created in the 1880s. A guy wrote a book and said that lie. There's no evidence for that. More importantly, though, for the story I want to tell tonight, no one is tortured or burned at the stake for their scientific views at this time. And that's contrary to what most people think. And here's an image I'll leave you with. A couple years ago, I taught a course when science and religion meet at Stanford, and one of the students found this for me, and I've used it as a title picture ever since. And it sort of gives a new meaning to forbidden apple. And also fig leaf, I guess.
Why does Adam have his finger up?
No, he's got his iPhone there. Just a minute. Yeah.
Oh, God.
Anyhow,
Hold on.
so I've skipped over a lot of interesting people. It's a problem paring this down to. I was aiming for just a little over an hour. I didn't make that by any means, but there's a lot of other exciting stuff that happened in this time, and for me, I'm always struck by how inverted the popular image is of the medieval period, in Islam as well as Europe, but particularly in Europe. And the key, I think, is that what happened in the universities.
Why,
So, yeah.
why do you think it is inverted?
Because in the late 19th century, there was a period where philosophy congregated around something called scientism. The great advances in science, particularly in European world, created this feeling that we can do almost anything. You know, telegraph and, you know, things going through space and machinery that could go underwater and fly. Well, they hadn't flown yet, but it seemed like everything was possible because of science. Scientism was the feeling that you didn't need any other explanation. And there were some books written at that time, 2 of them that were really influential, that had titles that were more or less The War Between Science and Religion. Cornell University was founded on that assumption. The first president of Cornell wrote one of those books, Andrew White. And it's full of these errors. Roger Bacon's problem with being imprisoned and tortured. Historians can't go back and find any evidence for that.
But where did it come from to begin with then?
Well, the spirit of the age, that science was really popular. And what happened, there was it's a long digression, but there was sort of a rebirth in the United States especially of interest in religion at a time when high school education became required. Up until that time, not many people went through high school, but when you had a required education and kids started learning some of this stuff, a lot of religious people suddenly were aware that their children were getting told things that violated their literal understanding of the Bible. And there was a wave of new evangelical feeling. The Scopes trial happened in the midst of all that. And so there was a sense of a war between science and religion, and it developed even more with the intelligent design folks. And today, I think we have, for the last 100 years, there's a strong popular idea that there is such a thing, and there always has been. And in fact, historians of science are pretty much unified around the statement that there was no such war. People like Galileo, for instance, were devout Catholics. It wasn't, they weren't opposing their religion, they were trying to protect their religion. There are many examples, but it certainly has changed in the last century. It's a long, long story, but that's a short overview, I think, of why. So it was a dynamic time in the Middle Ages, and I've spent a lot of summers going back to just spending time taking classes and going to libraries at Cambridge, and one summer at Oxford. I just hanging out around that kind of environment, I think, is very stimulating even today. Any other questions?
So, John, with the period when you have the rise of the universities, where are they getting all their books? I mean, this is still before mass printing.
Yeah, they're manuscripts.
Okay.
Yeah, but there's a lot of people writing. The monasteries, have scriptoria. The people who are trained to just sit and copy what they
We
see.
still don't have large private libraries, and I mean, the
No,
libraries
the
are
biggest
still
libraries were
central.
the Vatican,
Yeah, okay.
the cathedral schools, and then the universities started building up. Rich princes, would get libraries. But yeah, a manuscript was a very valuable thing. I remember I was fascinated at one period of time on the medieval Latin bestiary because I had seen one, and I loved reading what people thought of as a biologist, which was my background. A Latin bestiary, illuminated bestiary, was figured to be cost about the same as the cost of building a church in a village church, not a cathedral, but a church. So a cathedral might have a Latin bestiary, and very few other copies. And that was generally the case until, of course, printing came along. The problem with hand copying is that the people doing the copying were skilled craftsmen trained to do nothing other than copy. They didn't understand the math. They didn't understand what they were copying. And so there's some bizarre errors that are found in a lot of the manuscripts, particularly if it was mathematical. They would also, if there was an illustration, mathematical illustration, they would draw something that just sort of looked like it, but where lines crossed weren't really important to them, which would be essential to the mathematical argument. And so it was later when printing could standardize that process that some of the finer aspects of the ancient science and the new science could be preserved. That's it? Okay. Next time is Copernicus, and by the way, this is another person I think is greatly misunderstood, and I'm going to make an argument why there wasn't a Copernican revolution.